All right, Math B Honors students, welcome to 5.1D lesson on negative exponents and the power of zero. Okay, so this is going to be an extension of what we already know about exponents. Currently, we know how to multiply like bases and what we do with those exponents. And we also know how to divide like bases. But before we begin with today's lesson, I'm just going to remind you of what happens when we do see a negative exponent, right? So, for example, what if I said I have x cubed divided by x to the fifth, right? So, in the previous lesson, you learned that we are to subtract the exponents when we have similar bases. Uh, and we know that this would be x to the 3 minus 5, which technically is x to the negative 2, right? But let's think of it in another way, right? Instead of really subtracting the the exponents, what if I just did x cubed like this and I expanded it and then I showed x to the fifth like this, right? Then you would be able to see that uh, the amount each x on top would cancel with one x on bottom. You would cancel and you would cancel, right? So the result of this process would give me 1 over x squared. And I hope you're starting to realize something about negative exponents and how we convert them to positive, right? You can see that the negative 2, the negative exponent, really kind of made this base flip from the numerator to the denominator. And you can see that the 2 went to the bottom. Or, I mean, the 2 became positive, basically, right? So see the connection between x to the negative 2 and 1 over x squared. We're definitely going to go over this more, but I just want you to realize, kind of generally speaking, what does a negative exponent really become? Okay. So for that reason, let's go ahead and circle the statements that are correct. Explain your reasoning. Um, yeah. The thing we have to remember is the base will flip to its reciprocal if the exponent is negative, right? That's what the negative exponent does to the base. Okay. So unfortunately, though, you don't do 3 times negative 4 at all. Like, this is a silly choice right now. 5 to the negative 2. Well, we know that instead of 5 as the numerator, we then flip it to 1/5, and then we can switch the sign to or switch the exponent to positive, and this becomes 1/5 squared, which actually becomes 1 over 25, right? Because technically you're supposed to square the entire thing. So I would square 1 and I would square 5, and that would become 1 over 25. And 1 over 25 is indeed 0.04. So B works. Does C work? Right. Do you think C works? Right now, for me, looking right at it, it looks correct, right? 3 cubed is 27, and the fact that it is negative means that it is 1 over 3 cubed, which is 1 over 27. This will work, yes. D, well, this is kind of a misconception for sure, right? Just because they're both negative doesn't mean that I will have a positive square. It seems like it's uh, trying to confuse us with this. And basically, class, when you see a negative exponent, just remember that the base should be flipped. Okay. 4a to the negative 3. Well, just like we've been doing our entire lives, whenever you have something outside of a parentheses, you should think about distributing. In this case, we need to distribute the exponent to both of the terms, the 4 and the a. This is technically 4 to the negative 3, a to the negative 3. And one rule about exponents class is you are never allowed to leave a negative exponent as your final answer. It's kind of like saying it's not simplified. This is not wrong, it's just not simplified. So what you do is, what I like to do is I like to circle any term that has a negative exponent, and I like to push it to the other side. The other side being from the numerator to the denominator. Since both of these terms have negative exponents, I push both of them into the other side, and then I get 1 over 4 cubed a cubed. Then you have to also realize, class, that 4 cubed is not the final answer because you technically can calculate that, right? We all know that 4 cubed is 4 times 4 times 4, and that's going to be 64. So this is 64a cubed. That's the final answer, and that's exactly what it said. So E works. Okay. Letter F, 1 over 8 to the negative 2. Well, just because we've been working with terms in the numerator and switching them to the denominator, that rule also applies for anything in the denominator, right? So you can see that letter F has 8 to the negative 2 in the denominator. It really just wants to push it to the other side and go to the numerator this time. And when it does that, you end up with 8 squared, which then becomes 64. Okay, so F also works. All right, so that was a little bit of an intro to negative exponents. Explain in words how you simplify an expression with negative exponents, right? So let's use an example. A to the negative n is the reciprocal of a to the n, right? Basically, therefore, any negative exponent must first flip the base to its reciprocal before becoming positive, right? What I mean by that, class, is if you want your negative exponent to become a positive exponent, you're going to need to switch the base to its reciprocal, okay? If you want, I'll say that one more time. If you want your negative exponent to switch to a positive exponent, you're going to have to switch the current base to its reciprocal. So in this case, instead of a, I'm going to have to convert it to 1 over a. And then that would be, that would make the uh, exponent positive. Okay. And then the final for that would be 1 over a to the x would therefore be running a little bit out of space, but I'll write 1 over a to the x. That's probably the most preferred way to show the two. So a to the negative x is 1 over a to the x. Okay, so let's practice this. There's going to be a lot of practice in this lesson today. Okay, so I know that when we see the subtraction sign, class, we like to think, oh, it's 2 squared minus 2 to the 6th. Is that 2 to the negative 4? But that's a huge, huge misconception because we only subtract exponents when we are dividing like bases. Here, we're not dividing at all. This is literally just subtraction. So this is not going to be 2 to the negative 4 at all, okay? This 2 to the negative 2 squared, well, we learned in the previous lesson, product of powers, you're supposed to multiply these powers. So this is going to be 2 to the negative 4. And yeah, that's correct. That's B. But then again, 2 to the 4th divided by 2 to the 8th. Well, do we see that we have an excess amount of 2's on the bottom, right? You would say 4 2's cancel from the top and 4 2's cancel from the bottom, and that would leave you with 1 over 2 to the fourth on the bottom, which we've also realized is equivalent to 2 to the negative 4, right? So C does work as well. Okay. And then does r to the negative 3 equal negative r to the third? Okay. Explain why or why not. I mean, not that it can't be equivalent, but in this case, no, that is not correct, right? R to the negative 3 is equal to 1 over r cubed. That's totally different than negative r cubed. Negative r cubed is literally negative r times negative r times negative r. So you're going to have to distinguish between the two. Again, not saying that they can't be the same value. If r was negative 1, then technically you would get the same value. But in terms of the expression and how you expand it and how it looks, they are not the same, right? So this is no. The two expressions are different. They look like they would be similar, but they are not. Okay, so that was a lot of information, class. I say this so often, but more often than not, the more you practice negative exponents, the easier it will become. So let's go ahead and go to the next page. Number 6. Claire believes that the expression 2 cubed times 2 to the fourth to the negative 1 power and 1 over 2 to the 12 are equivalent. Is Claire correct? Okay, so first of all, let's ask ourselves, what's 2 cubed times 2 to the fourth? Well, we know that because they have the same base, 2 cubed times 2 to the fourth is 2 to the seventh, right? So you can already tell they are not equivalent. If we were multiplying the powers, then it would be equivalent, but we're not. We're adding the powers. You must add the exponents in this case, right? So no, they are not equivalent. We're going through a lot of misconceptions in this lesson, so I hope you're paying attention. Okay, wow, 7 is also a very, very important question. You have to distinguish between 6t to the negative 2 and then 6t to the negative 2 with 6t in parentheses. Remember, class, if you don't have parentheses like you see in this first expression, then that means the negative 2 is only attached to the t. That's why I like this diagonal oval method. I literally circle the exponent with the base that it's affecting, and I don't circle anything else. Notice how I did not circle the 6. Okay. You then drop the t to the other side because that's how you fix the negative exponent. Okay. I kind of think of it as the exponent is not happy. It wants to go to the other side. And once it goes to the other side, it becomes positive again, right? So the 6 stays, the base t has to switch, and then this becomes positive. So it's 6 over t squared. Whereas in this case, in this situation, the negative 2 has to be distributed to every term on the inside, and you end up getting 6 negative 2, t negative 2, right? So technically, both of them are negative, and that means they both have to switch to the other side now, right? I'm going to draw this animation, but really it just means that you're switching both bases. And this becomes 1 over 6 squared t squared, which we still have to simplify to 1 over 36 t squared. So you can see that even though they look very, very similar from the start, that parentheses really, really dictated the difference between how we distributed the power. Okay, so no. The answer here is no, right? Okay. You can already see that 8, they probably won't be equivalent, because here again you're distributing the power, whereas here you're not, right? You only have the power on one term on the 5. But let's go ahead and distribute. So you get 5 over 3 uh, raised to the negative 3 power. So I'm going to go ahead and distribute that negative 3 power. And you can see that now both of my terms are negative. So what's happening here is both bases must be switched. And I kind of show this method. Kind of looks like a football play almost. But you can see that I'm trying to switch both bases, and now the 3 goes to the top, and then the exponent becomes positive, and then the 5 goes on the bottom, and then the exponent becomes positive. This ends up being is that 27 over 125, right? That's the first term. The second term, we only have the negative exponent on the top, so I circle it and I push it to the bottom, and then the top is actually left by itself. It has nothing left, so it's just 1. Anytime you switch something from the numerator to the denominator and there's nothing left on the numerator, that just becomes a 1. And then the bottom is 3 times 5 cubed, which ends up being 1 over 3 times 125, which ends up being 1 over 375. You can see that that's totally different than what we got here. Okay. I think this is a perfect time to take a break. I think this is a perfect time for you to practice on your own. In class, I would probably ask you to try number 9. And you can see that the next page has a lot of practice problems. So go ahead and try these problems on your own.